start. First of all, this is a complete new slides. I hope everything works out. There's a lot of animations in there. Hopefully that works. So it's the first time I try this, so sorry if something goes wrong. We will get that sorted. But let's start first. Who am I? I'm Sebastian. I'm the founder of Smested, and I'm working part-time still as the chapter lead in backend for the Better Ventures. Better Ventures, a bit more known, might be the company Kartenmacherei. This is the main brand of Better Ventures. We are working simply on everything which is print products and related to emotional events, especially now Christmas season is one of our peak, where we have a lot of like Christmas cards and already starting wedding invitations. But enough about that one. Let's come to the topic. What do we want to tackle today? Let's first have a look on the problem, then I show you our solution, explain a few things on our rules, then I show you how to add even more projects in Docker Dev-Env, and if we have time at the end, let's try if we get some live coding done. I have my own internet connection, so that shouldn't be an issue today, but let's start with the problem. So the problem is, I want to explain the problem on an example, and the example is you want to onboard a new employee. The solution I want to show you today is mainly the solution we found. We know by today that there are other solutions. If you have other solutions found for what I show you today, please approach me afterwards and let me know how your solution looks like, because I'm curious to see more. I'm curious to know how others solve the same problem. But let's start. So imagine a company has several applications, some cron jobs, some elephants running somewhere. They usually need databases and storages. They have some configurations, they have some deployment scripts, and they might have even mailing and business intelligence tools. All of this is running somewhere in the internet, maybe in cloud, maybe on-premise. But developers tend simply to work locally. So it's all the time difficult to get different PHP versions, different kind of applications running on your local machine. So there was in the last couple of years a really tiny feature came around the corner. You might have heard it's called Docker, and that helped a lot because you can now properly encapsulate applications in their own environments and run them locally on your machine. But it's not just one developer used to work locally, but several developers. And imagine you have an additional developer, and that usually takes time to get them on speed. And let's have a look on how the share is in the first days of a new developer in a team. So the developer starts simply with paperwork and learning about the company. Then we add up the time for configuring a computer and setting up the work desk, like is it 1 screen or 3 screens, or what's the stake? And then we have 60% of the time is setup and debugging, because usually nothing works. If you start on a new machine, if you clone, you get the information which repository you should clone for getting this task done. And that's sometimes if this task is across several repositories, you need several repositories. They somehow need to work together. Then you need to know, okay, there I have this and this port mapping. It's a lot of debugging because this person doesn't know the tricks yet. So we end up with a value addition of the first couple of days of simply just 5%. It increases over time, sure, but we usually say in the first 3 months of a developer, there is no proper value addition, because the value this person adds, he needs in support from other developers. So we said, okay, how can we get this problem optimized? How can we get these people up to speed earlier? And we needed a simple and fast and quick solution. And at this time, we simply said, looked, what do we have there? So we simply have this running in the cloud. So we moved, and we have these kind of repository setups. So on a computer, on a local developer's machine, on a new machine, we have a web front end. We have the transactional mailings, and we have somehow a web backend, or BI, or whatever. But the problem is, they all share the same ports, because you usually work local with localhost, so you can either have the same ports or somehow get the local host and then have different port mappings. But how about that? If they need to work together, localhost pointing to port 81 from one Docker container to another Docker container, that doesn't work. So we have a problem there. So in the end, we identified these as our main problems. So we have the local host, or each project is using localhost. Each repository uses the local ports of the machine and has own Docker Compose files. So the own Docker Compose files is with our research even a benefit, because the knowledge should stay in the repositories. So of how to run that. So what can we do there? So we defined that we need a new script, a new script box. So this is a new repository. I called this now Docker Dev scripts. We will get to that point later as well. And this Git repository doesn't know about how to build each project. What it does know is how to build a Docker Compose file, how to run based on a Docker Compose file, how to stop it, and with this small list here, it knows which kind of repositories it needs. So when we run the build or the install script, it simply will install these repositories which are configured into this system, and then you simply can run that. So with the benefit of this, we have already for a new developer with the simple shell scripts, all repositories available. So the new developer only needs one Git repository for the beginning and gets all projects. So that's the benefit. But we still have this problem that they can't talk properly. So how did we solve this one? We solved this one simply with a reverse proxy. Who knows what a reverse proxy for Docker is? 1, 2, 3, 4, 5. Okay, good that I got the slides with that. Just short, with a reverse proxy, you don't have these problems anymore of that they can't talk to each other, that they use the same ports on the local machine. But a reverse proxy is simply, or there are two reverse proxies we use for several kind of Docker Dev-Envs. There's one from Jason Wilder. That's for a simple version. If you have simple projects which are just talking via HTTP together, that is then you can use the Jason Wilder, and it's even providing with the link I have there. It even provides HTTPS. So it's already in there, or you can use it's a bit bigger. It's a tiny bit more complex to get the initial configuration done. But that even gives you opportunities to talk from Docker container to Docker container directly. So based on host names. In the example I show you later, we use the Jason Wilder version because it's a simple example, and that's even configured. But Traffic has the better graphics for us. So to explain shortly again what a reverse proxy is. A reverse proxy is simply a daemon, a kind of an application which is monitoring the Docker daemon and knows which kind of applications are running in Docker. So you can run as many applications in there as your hardware can handle. And the daemon and the traffic in front of it, or the reverse proxy in front of it, is checking what is there based on configurations. It's even getting domain names, and then you simply can forward domain names, real host names, to this traffic and to the reverse proxy, and the reverse proxy is then handling everything internally. And with traffic, like even stuff like load balancing is possible. So if you want to test something with load balancing, you can use that. Traffic is even there for which can even be used in live environments. So it has quite a community. I didn't expect that. So to even traffic, and as I mentioned before, the JSON Wilder example has HTTPS. For the JSON Wilder example, you need more than just that reverse proxy from JSON Wilder, but as well there is a Let's Encrypt companion, and if your machine is publicly available and these domains are publicly configured already to this machine, then you could even set up HTTPS. So we have, for example, we don't use it in a production environment, but we have, for example, our testing environments where we have even HTTPS, which are available from the outside. If you know the URL, they are even supported with Let's Encrypt, and even with the short lifetime of these SSL certificates, it recreates the certificate completely on its own, so nothing to worry about, nothing to care about. It simply works if it's configured. Good, but let's come back to the system and let's have a look what changes we need. So, and the first change is we need to take off from these projects the port mapping to port 80 and port 433. No, 443, sorry, the SSL ports. Because they have to stay up here. They are needed for the reverse proxy. Everything else should simply expose port 80, what you configure, but should not use it. What we did, for example, especially for databases and development, sometimes you simply want to have a look into the database. You can configure that in two ways. You can either use like logging into the Docker container and then via the host name, and then simply connect there to the database. Or what we do, we have a simple list which is part of this repository of the Docker Dev-Env or the Docker Dev scripts. There is simply a list in there which repository owns which port, which database port. So we can still run them next to each other. They are not interfering with each other. It's just simply that project has all the time 3306, that 07, that 08. So, and that's fixed. This is configured once, and if you want to introduce a new project, you simply add this to the list. So that's one. But to run all of this with the reverse proxy on your local machine, you need somehow host names. So in local computer usually doesn't support host names out of the box. So, but there is, I guess everyone knows, there is the file etc hosts, where you can simply match host names to your local host. So, therefore, we introduced another kind of small script and small list into the Docker Dev scripts. And if you run the install sh, it will even do this for you. So if the domain is configured, it will even introduce this domain in your etc host file and will mark it with the information. This is the, like Docker Dev scripts will add a comment at the end, so you know if you want to at some stage you want to clean up the etc hosts file. That's coming from this environment. You can delete this. So with the next install, it will take care of this. So all of this is even that is introduced in the Docker Dev scripts. One more thing we need to change is, or what we need to add, is to configure to node or to notify the reverse proxy under which name this application is running and under which host name an application is visible. We need to add really few configurations to the Docker Compose file. For us, we even identified to not put them to the Docker Compose file directly, but to put it to a Docker Compose override. So the Docker Compose stays clean, to say, okay, the Docker Compose file only knows how to run, what kind of environment variables are necessary to run the project singly. And if you want to run this project not just singly, but in a Docker Dev scripts environment, or together with others, then in the Docker Compose override file you find the configurations you need. And Docker Compose by default looks for this file. If it's there, it takes it. If not, it takes the default one. But as promised, there's the barcode. Don't worry, you don't have to rush. It stays for a couple of slides. There's the barcode. I extracted this whole project into an own Git repository, or not just one Git repository. In the end, it's actually 4 Git repositories because it's a full example with 2 applications to build in. And if you look into this one, it will only build actually with 1 real application in there because there's a branch for the second one. So you can see actually, you can do a diff between the 2 branches to see what do I actually have to do in order. All of this is pretty new, so sorry, the README exists, but in the README you find simply just headlines. So this is an open project, so if and in there I'm a PHP developer, as the most of you, I guess, and I'm not the best shell scripter in the world. So I never learned shell scripting. This is simply okay, try and error, or everything you find in there. If you see bigger gaps, if you see any shitty code in there, I'm happy to get support on that one. So because this is simply it works. It works now for 3 years. So it works across several environments. We checked that it works on Linux. We checked that it works on Mac. We avoided Windows, sorry, because that, no comment. But it works on both environments. We checked that. There is still the usual fight between Linux and Mac, but that is project related. That UUIDs, so that you have some issues with UUIDs, that you have some issues with that one. But let's have a look what kind of features we have. So there is, because it's not just what I just showed you, like the install, build, up, stop, down, all of these everything is there. And these are simple shell scripts which are nothing else doing than checking, except the install, checking if your environment, goes, let's take it like this. It goes through the list of projects which should be built, checks if they are there. If they are there and they have a Docker Compose file, then it runs the build, up, stop, or down command. You can override them, pretty simple. I will show you later. We have, in the install, we have, as mentioned before, setting up cloning repositories. On top, we have setting up the domains in your etc hosts file. All of this is in there as well. But on top, we have some backup and restore features. Because what I used to do is, okay, I messed up this project, including my Git commits, and everything is messed up. I simply want to delete this one project. So this one environment, not the whole Docker Dev scripts, but the web front end, for example. And I can simply run the install sh script, and it will pull it again. So it will clone it again, it will set it up again. But then I realized, oh damn, I forgot a few things to back up first. First, the idea folder. So we used to have the idea folder. This is the configuration folder for PHP Storm. We love to have them in the projects. So, but in there is usually like configuration for the database, configuration to whatever remote hosts, configuration for for specific settings for the project. All of this is then gone. So we set up, okay, let's back it up. So let's have a backup and restore feature. So if for this project which gets installed, an idea folder is existing already in the backup folder, then it will restore it. So you simply restart your PHP Storm on that project, and everything works as usual. But it's not just the idea folder; it's as well the .env file, and it's as well the Docker Compose override YAML. So because there is usual, these are usual in our environments, are not versioned. So we have them in the git ignore file, and there we solve that by simply backing it up and restoring. So, and that usually works on the backup, usually works on any kind of script. Like at the end of any kind of script, if it's up, stop, down, build, these folders are getting backed up. And on the install, it checks first, do I have something to restore, or do I take the dist file, which is usually versioned in the project. Good. Let's have a look on the folder structure. Folder structure is pretty simple as well. We have the apps. So what should be in there? The applications. So that's where the shell scripts will clone all the repositories into. We have the environments. It's a bit more strange name because that's the backup folder. That's where all the configurations and all of the stuff gets backed up to. And we have a scripts folder. This is pretty much the place where we have some internal scripts, like how to back up the idea folder, how to restore it. All of this lives in there. In there we have the default folder. That's where all the default scripts are in there, because you can put next to the default folder simply in with the same name as your application another folder and then introduce own app scripts or own build scripts if you need to overwrite the initial scripts. So you can set up your own scripts there. We have the domains txt. That's pretty much the file which is needed, where you have all the domains in there which should be added to the etc hosts file. The projects sh in there is pretty much the list of repositories you want to clone. And as usual, as mentioned on the lowest level, just as an example, the install sh, up sh, all of these. I mentioned especially these three files, because these three files are the files you need to change if you want to configure this whole Docker Dev script for your own projects. So the first one is you need a git dsn in the install sh script, so that is pointing to my place, so to my GitHub. You can define yourself if it's GitHub or Bitbucket, or if you want to have the full one, if you have them across several repositories or across several namespaces, then you can configure, then you can take this part here. This is simply concatenated with what's in the project sh. And in the project sh you find the project to clone. And I have to say, we haven't tested this code yet across several Git namespaces. Because of the slash in the namespaces, that might get some conflicts on the cloning into the right folders. Might be, haven't tested it on that version yet, but it simply clones. It simply needs here in this list the order to clone, and not just the order to clone, but the project sh is the main file for pretty much every job, every task, every shell script. Because in there it knows which order. So usually you want to have on the first place the proxy. Because if the proxy is booted and you have 20 projects to clone and the first one is the one you need, let's clone it, let's build them, you can already use the proxy. There's one more thing to change. As mentioned before, we should add the domain in the domains txt, the domains which should be added to the etc host. For this example, I took the dummy A. All of this, as you see it here, is already in this repository configured. So you can simply take that, run it, see that it works, test it, and then configure it to your need. That's the configuration of the Docker Dev scripts. But as mentioned before, we have to configure a few things in the Docker Compose override. And we, as mentioned before, we even have a dist file. So we have the dist on versioned to the Git repository, but on install it will simply copy this file and take it as it is. But that is not versioned, so you can change configurations, you can change host files, virtual host names if you need, and they are not getting spread across all environments immediately to every other developer. So you're not destroying each other's work. And in there we defined a few things. So this is the configuration for the JSON Wilder proxy, and there you have the simply just an additional environment variable which is called virtual host, and then the host name. And what you have to make sure is simply the network, that all of your projects are using the same network. If not, they simply can't see each other. So, and that solves the problem with the networks. There is a few more details, there's a few more hints, which for us actually turned out to be a benefit. If you're in your project A and your project B, your PHP containers are called PHP. That gave us some trouble, because we ended up on the wrong. Better in this case, what we used to have, there is an additional information in here to the container name, and put in here a container name which is unique. So your service still can be called PHP. You have, if you want to boot this manually or up and down, you don't have to have the full container name all the time. But we have in the container name in this file here usually like Docker Dev scripts _ dummy a _ PHP. So it stays unique across all systems, and no automatic load balancing, which might be possible in these systems, are kicking in. Because if you're ending up on a load balanced PHP server, and only every second request goes to the server you want, that's trouble. So, but let's have a look how installing looks like. As mentioned, we will try this later on my computer if we have the time. But let's have a look how this looks like. So last opportunity for the barcode, if anyone needs good. Okay. So that's how the install script will look like in the end. Shortened it here a bit for the cloning. Shortened it a bit by building, because the containers were already there, or the images were already there. So, but in the end, it starts with the cloning. So it simply clones all the repositories. What the install? Sorry, I forgot to start at the beginning. What the install script on our end is doing is it's checking first if you have Git installed. It's checking first if your Docker is installed, so that these commands are existing, so that you actually have a working environment. So it would even not start for a new developer if this developer is missing Docker. So we have at Kartenmacherei, we have a few more features in there, because we have there some additional features for Ant, so we check even that the Ant environment is available, so that Ant scripts can run. That is done at the far beginning. Then at the first one, you need to enter your password of the machine. Don't get scared. You can have a look. The code is simple. If you don't trust us, don't worry. What this password is needed for is simply for the etc host file. So you can't change the etc host file with your normal user. So therefore, we need shortly at the beginning the password just for adding these lines. Please have a look. If you see there's some security holes, I'm really happy to get their support, because it's a one-man show to maintain that, and it's simply just live, that code, because the other projects are based in the companies. For example, in Kartenmacherei we have already 2 of these environments, because we got so big and have some applications running completely independent. So we have 2 environments like that. But yeah, if you have more details, happy to get more information on that one. So, but as mentioned, next cloning. Then we check if the override is in the backup. If not, it will copy it from the repository. So it will copy it from the dist file. Same for the dummy A. Then it will do the same with the env file. So it will copy the env file from the env dist, because it's not there yet, it's not backup yet. Then it checks if this repository has a Docker Compose. So sometimes we have repositories which are just libraries, so they don't need anything to run, but they should be part of the code, they should be part of this environment, they should be available to change their code. So we check if the Docker Compose file is there. And if yes, we simply run the Docker compose up -d on the whole file. So the same then for the dummy. And then you see here, backup directories weren't there, so it creates in the environment the Docker Dev proxy. It backs up the Docker compose file. It backs up here the Docker compose file and the env file, and then everything should work. So to test this, simply, that's what the dummy is doing. Nothing more. You can, if the install was properly working, you can simply run the domain on your local machine. Everything should be there, and that is for the next steps. Because the next step would be, okay, why should we do this with one project? Let's have a second one. The second one is simply introduced. Most of the configurations we saw already. So let's have that in a different way. I simply put the diffs from GitHub. So we simply add the second dummy. We simply add here the second dummy. But the second dummy is not exactly the same. But the second dummy actually has on install to run, needs some composer dependencies. That's the usual behavior that we have to get if we want to get projects running, we have to get some additional steps done. And that's what I mentioned earlier. You simply can override the install sh script on project base by putting it into this explicit folder structure. So on the scripts, create a folder of your project and put the install sh there. By today, we already figured out that even that shouldn't be in here, but should be part of your repository. We haven't managed yet to change all our repositories and all our projects in this way and get to check on a specific. At Kartenmacherei, we, for example, have this way, plus the feature in Ant. So the Ant script is checking if in this project is a build XML, which is called then build project. And if in this build project file is an install or a setup command, and then it will run this on top. So in this case here, it's pretty simple. Give you a short heads up, standard stuff at the beginning. We have adding some colors to get better outputs. Getting into the directory, running Docker composer install, and going back. So not pretty as mentioned. If there are better ideas, please, I'm happy to learn. But good part. We made it through all the slides. Let's have a try if we can do this time live coding without something breaking, okay? Good, and feel free to start ask questions in the meanwhile, so we can talk. Let's have a discussion. Main slides are done. Now the good stuff starts. Feel free to start asking questions. Let me just mirror. That should work. Good. Good. So, as mentioned, it's pretty simple. Just cloning. Hopefully that works now. Yep, it takes a while. So, cloning this repository. Then going into the Docker Dev scripts and then running simply install sh. Yep. That's it. And now it's installing. So in the end, when new developers join a team, or even if you get a new box, or if you had problems before, all of this is pretty simple. The only thing you need to know is which repository to clone and how to run the install sh. And then the rest is already there. So we can have a look. Everything is in here. So we have, that looks better. So we have the backup, the apps folder, as mentioned. We have the environments folder, as mentioned, and then we have all these commands like even backup and restore settings. To see if it's working, let's open the browser. It works, but the second is still not there. So it's still not there, and now because I clicked, I guess it's not running. So the first project is working, as we saw here. It installed the dummy A, but not dummy B yet, simply because of the wrong branch. Check out, git check out. What is the branch name? Let's have a look. Let's have a look. I forgot the branch name. Two branches. Introduce dummy B. Okay. Nope. Introduce dummy B. Track. Okay. And now I can. In there is, as mentioned, in there is everything we saw earlier in the div. I can simply run the install sh again. So it won't clone all the others. It simply will clone only the dummy B. And this time, because I simply was running this fast enough one after another, it still had the knowledge of the or the root, the sudo access to the etc hosts file. As you see, it's a dummy project. Nothing major to be installed, but it is running the install sh. It's override. It took the override, but still did the rest of it as well, like booting it, making sure that everything is there. All of this. Yep.
In your company, you end up with a lot of files for a lot of projects, and when you do like an install and you want all containers, developers start to complain about it because the machine starts to be slow. You have a lot of projects running at the same time.
Yes.
How do you solve that?
In a simple way, instead of having just one up command, which is booting everything, you can put this, you can tear this apart. What we did as well, we did it first in a simple way. Let everything boot and then kill the containers you don't need. So we had on our local machines individual kill sh scripts, but that was cheesy over time. So first, why booting everything up? So we simply introduced not just an up sh, but for example up order checking sh. And with the order checking, you need simply we need for us an FTP, an SFTP, a database, and an application. All of them are getting in. These are across two repositories. So we simply run across two repositories some up commands, but not everything. So because it's simple shell scripts, we can have a look. We can have a look on them. I opened all of them. So the install is one of the most complex. I know that is far too small. Give me a second. Presenters. Sorry? Yeah. Ah, there it's gone. Okay. Okay, good. Is that, especially for the last lines, last rows, is it big enough, or should I? Is okay? Okay, good. Yeah, as mentioned, here's the git DSN. Then we check if, because we use the SSH keys for authentication, so we check if your public SSH file is there. It currently has some issues, this version explicitly has some issues if you have a passphrase in front of it. So we have this solved in other projects that already with the passphrases, but that code was so cheesy that I didn't dare to put it in. But yeah, there is currently a problem if you have a passphrase in front of with your keys. Then it checks if your Docker Compose command is available. here's the update host files. So that's the code which needs the password, which will run your etc host file, like adding domains to the etc host file. That is the projects sh. There's the list of repositories in there again, and that there's in there not just the repositories, but there's in there like a map, so we can check if something is cloned already or not. And then we simply run through these list of projects and check if they are existing or if they should be cloned. Then we restore the settings. So that's simply just calling the other command. And then we simply check if the install sh needs to be called. So if as we saw it, the install sh installed Docker Composer dependencies, and if I run the install sh again for this directory, it will not run the install sh again. So it will not run the cloning again. So because that might affect if you have fixture files or configurations which need to be generated, and all of this is run again and again and again, that causes trouble. So, and it's the same with the up sh. We can have a look to show you what is needed. Come on, let me exit presentation mode. Dear computer, thank you very much. Let's fix that one. So the up sh. Let me zoom in here. Makes it easier. So the up sh is pretty simple as well. To answer your question, we simply for the up sh command. So what we did in this command to simply just run a few of them, we had an own list of projects which should be run, and then we reused pretty much the code from here. So to run each project's up command and then simply have that sorted in this way. So you don't have any requirements to use this. So to have it all the time booting everything. But then you usually have not just one repository you need to run together, but maybe 2 out of 5. So to work them together. So for your field, but the other one needs one of yours and 2 others to run. So you can extend it in this way. Pretty simple. These are all small scripts.
Why decide to go with shell scripts instead of something like Ansible or any other automation?
We thought about Ansible. Simple answer to Ansible: no knowledge in the company. So that's the simple answer. We thought about Kubernetes. At this time, too much to configure. Today we have it all with getting it for the Macs already with Docker for Mac. It's Kubernetes introduced already. Simply wasn't at this time. So that's the simple answer. We needed a quick solution. We needed something to get this running because we were in a state that we moved away from Vagrant, and we had a really, really nasty Vagrant box with, I think, 5 different PHP versions installed, and everything so much configured to work on a local machine that it doesn't fit any live environment anymore. And with Docker, and this time, really, Docker came around the corner, like quite big. I think it was the 3rd or 5th birthday of Docker, or whatever, 3 years ago. It came around the corner, and we said, okay, come on, let's Dockerize everything to make it run on your local machine, because we ended up standing with, I think, 5 or 6 senior developers in front of a damn Windows machine, and we're trying to figure out why this Vagrant box is again not working on this machine, while it works on the next one. So we took 2 steps. First, we introduced Docker, which significantly made our life easier because you can run as many PHP versions as you wish. And I have defined for my computer already that on my computer I don't use PHP at all. So just Docker. The only thing I need to have locally installed is Docker Compose plus Git. Everything else is done inside Docker containers. Like even if I work locally or if I run tests locally, I usually connect to a Docker container and run it in this environment because that is as close as possible to our live environment. So, yeah.
Then I have another question. If you want to compose an install and you clone in private repositories, how do you work around with the SSH keys?
The SSH key, you can simply solve this problem if you because it's your local machine. Mount your SSH key into the container.
Okay.
So that's how we use it. Everyone is saying, and don't do this. I agree. If we are talking about AWS, if we talk about production environments, if we talk about environments which are far away from your local machine, but it is your local machine. If you have if you mount your SSH private the public and private keys into your container, the only thing you shouldn't do is really build them into the container. That you shouldn't mount them in via Docker Compose, and then you don't have these problems. So, and that's how we simply solve that. So it's a different story if you want to run these containers then live later, but they usually differ a bit. Okay, do we have more questions? This project is not with traffic. This project here is with the JSON Wilder way. That's the container. So in the repository, in the Docker Dev proxy repository, you find in the README file 3 links. These are the 3 links to helpful articles which I used to get this running. So, and especially the last one, that's the one I had earlier in the slides. And that's how simple it can be. So this project simply, or the reverse proxy simply doesn't know anything about other projects. So the reverse proxy, the only thing the reverse proxy knows about the Docker Dev-Env is simply that we have here as well, let me zoom in here, a Docker Compose override YAML, and that simply adds the port mappings and that simply adds the networks. So, and that's all. So because the reverse proxy is explicitly listening to the Docker daemon and gets all the information from there. In the case of traffic, you get even you should not just map these ports, but you should map another port. I think it's 8080 or 8088. I'm not 100% sure on the detail, because there you get an application, web front end for traffic, which shows you which containers are available and what names they have, what domain names they have, how you can get to them. The configuration on each project is pretty simple, as mentioned in here. So here in this example is even the Let's Encrypt host name. So if you want to run this dummy on a real server available from the outside, so you simply take these comments away, and it has SSL. Sorry, it has SSL. And for the configuration for JSON Wilder, you have to have a virtual host here. For traffic, you have to add a label. So traffic is using the labels of the containers to not interfere with the environment variables. So to not have their issues overlaps on that one. So they have decided for labels, and it's kind of a bit of a special way to write them. But that all of this is on the website of traffic, and traffic took us maybe half a day more to make it work. No. Let me see. Let me see. Zip. That is our old version. This is really an old code. There should be the proxy. So this is, for example, the proxy image traffic. You have to run this command, and then you have to add here at the bottom. Zip. So the Docker socket, and you have to add a traffic toml file. That's why it got a bit more complicated, because it would work without. it would work without, but it didn't work well without, and we wanted to have like self-signed wildcard certificates in there, because this is really the first version we built 3 years ago. So that might be not up to date anymore, but this and actually this traffic, and for some reason I didn't figure out, didn't start at the moment. I wanted to boot it yesterday evening. Maybe it's because of the new Mac OS on my machine. I didn't figure it out yet. But yeah, that's pretty much what you need there. And then if you have a project running, let's have a look. For example, on an FTP. So if you want to have an FTP running for traffic, you need simply that one. So you need to have here some aliases, a bit more configured, and all of this then is needed to get it working. But the benefit of this is if it's not an FTP, but for example a database, you simply can run even internally, like inside the containers. You don't have to map somehow the other container and use their container names. You simply can use the host name. So that's the benefit of traffic. So you have more, if you really have applications which talking from one container to another directly, not via HTTP, then traffic is your better friend. So because traffic has their more features, has their more benefits for internal communication, while the JSON Wilder approach is simply making it available to the outside, making several applications, independent applications to the outside. So if it's like in our case with the dummies, just a front end and a back end. I didn't even try it yet. I see. Yeah. So so if you have like between A and B, you can simply click back and forth. So you see here, this is B, this is A. So you can click back and forth. That works with the reverse proxy. But if the containers have to talk to each other, it is, and you want to expand your project, it's better to use traffic, because traffic has their more features, has their more benefits, has their more opportunities. Okay. More questions? Sorry, say that again, please. Yes. Yes, yeah. That's what I meant with, I can show you that as well, which one I use there. Docker Dev scripts, and that is, no, that's the proxy, and it's in here. Let's zoom in here. So that is the configuration for the JSON Wilder version. So, and below here it's the Let's Encrypt. And yes, I agree. You're right. This machine needs to be available from the outside. So the HTTP approach for the Let's Encrypt is on your local machine simply not working. But if you have this, if you want to run this, for example, as a test environment, as a stage environment to test some features, or just have some specific branches for feature testing available on a real machine, which is available from the outside, then as mentioned, as shown in here, you simply activate these two lines on that explicit machine, and then the Let's Encrypt really does this handover and check that everything is there and validates. So that when you don't even see that. Okay. Mm-hmm. Okay, that's quite nice. That's a quite nice idea as well. Mm-hmm. Mm-hmm. Yeah. Okay. That's a good idea as well. Yeah. Yeah. That's a good idea as well. As I showed you a few minutes ago, our old box simply had self-signed. So we self-signed and okay, you had to click. This is a self-signed. Yeah, I know in the browser, but that is simply on your local machine. No one cares if you have to click this second time. So, but yeah, more questions? Good. If not, we are pretty much kind of on time, 5 minutes early. But then I say thank you very much for joining. Thank you for the information you gave me. And happy to get more details, so please approach me afterwards if you have more details, if you have more questions. I'm here. Okay, thank you.